Hello everyone, I'm Jayesh Chak, Btech CSE student from IIIT Vadodara International Campus, DU. This PPT is on hydroelectric power plants and how they work. So before we start, let's have a quick look on what we are going to discuss in this PPT. Initially, we have a brief introduction on its history and power plants. Then we will be seeing components and working principles of hydroelectric power plants, like what is the initial requirements, role of turbine and generator, and how power get further transmitted. Then we have types of hydropower plants and some factual knowledge to cover. Now, for over thousands of years, humans have been harnessing energy from water to accomplish day-to-day tasks such as grinding of wheat into flour using water wheels, irrigation using Archimedes' screw, etc. But the invention of dynamo has become a significant step in history of our civilization, as now we can use water to generate electricity and perform several complex tasks. But the question is how electricity is generated and how it reaches our homes, offices, and buildings. Power plants are industrial facilities that burdens this task of electricity generation and transmission. These facilities convert mechanical energy or thermal energy to electrical energy using huge generators and that too from primary energy sources such as coal, oil, natural gas, water, etc. And based on that, they are divided into different types of power plants. For instance, hydroelectric power plants, solar power plants, coal-fired, diesel-fired, gas-fired power plants, and so on. Each of these power plants require basic energy as a fuel to operate. There are these renewable energy sources which get replenished over a period of time. Example, solar, wind, tidal, etc. Then there are non-replenishable energy sources, also known as non-renewable energy sources. Example, coal, diesel, gas, these are some kind of fossil fuels, and etc. Now, here is the illustration of how a typical hydroelectric power plants work. And as you can see, a dam is constructed on the face of river or water channel to create a huge reservoir of high potential energy water. Now, based on our requirement, we can channel this water through a tunnel, and then when that stream of water hits and rotates the turbine connected to a generator, electricity gets generated, and that and then transmitted over the transmission line to the customers. As I said earlier, that different types of power plants require different kinds of primary energy sources as fuel. Hydroelectric power plants harness potential energy stored in reservoirs, water, created by damming a water channel. Here is the status of fuel selection over a period of time. Due to rise in exhaustion of non-renewable energy sources such as fossil fuels, etc., demand for replenishable energy sources such as water, solar, wind, tidal, etc., came into picture, which you can clearly depict from these charts. Since they are more reliable, economical, and eco-friendly energy sources, they are they are more likely to replace conventional energy sources. Stage 2 consists of rotation of turbine. The force of falling water pushing against the turbine's blade causes turbine to spin. The turbine's role is to convert kinetic energy from flowing water into mechanical energy. Turbines come in different shapes and sizes, and they are used accordingly. At stage 3, connected to the turbine by shaft and possibly gears, so when the turbine spins, it uh, causes the generator to spin also. Converts the mechanical energy from turbine into electrical energy. Generator in hydropower plants works like works just like the generator in other typical power plants. This is a block diagram of hydroelectric power plants. So initially we have a speed governor. It maintains the speed of running engine by controlling the amount of fuel supply to the engine. Then we have servo motors. Servo motors are electronic devices and rotatory or linear actuators that rotate and push parts of the machines with precision. Servos are mainly used on angular or linear positions and for specific velocity and acceleration. Then we have hydraulic turbines, or actually turbines. Then we have simple synchronous machines, or we also call them generators. Then we have an excitation system. This system, which provides DC to the synchronous machine field winding to produce protective and control functions of the power system. Then we have a step-up transformer, uh, which transmit the output, voltage to a very higher level to overcome the different kinds of losses, which we are going to see in further slides. Then there is load, that is customers. These are the basic terminologies mentioned in the previous block diagram. You can see it. Now, stage 4 is the transmission of power. Transmission of electric power is a process by which the electric power produced at power plants is transported in bulk quantities over long distance for eventual use by consumers. Electric power is sent from generating power plants to the end consumers by transmission lines. Transmission lines, when interconnected with each other, become transmission network. This transmission network, along with power station and substation, is known as transmission grid, or simply grid. A typical transmission grid is shown in the below figure. Energy is usually transmitted within a grid with three-phase alternating current. Due to involvement of large quantity of electric power and due to property of electricity, transmission involving long distances normally takes place at high voltage. Electric power is usually transported to a substation near the consuming point, which is either a populated area or an industrial complex at the substation. At high voltage, electric power is converted to lower voltage suitable for consumers use and then transported to the end users through low voltage electric distribution line. Uh, on the further stage of this transmission of power, transmitting electricity at high voltage reduces the fraction of energy loss to resistance, which varies depending on the specific conductors and current flow and length of the transmission line. For a given amount of power, the higher voltage reduces the current and thus the resistive losses in the conductor. Transmission efficiency is improved by increasing the transmission voltage using a step-up transformer, which has the effect of reducing the current in the conductor whilst keeping the power transmitted nearly equal to the power input. Reduced current means lesser core loss in the system. Less cross-sectional area of the electrical conductor cable means less capital involvement, and decreased current causes improvement in voltage regulation of power transmission system. And improved voltage regulation indicates quality power. Because of these three reasons, electrical power is mainly transmitted at high voltage level. Substations transform voltage from high to low, or the reverse, or perform any of these several other important functions. Substation varies in size and configuration between the generating station and consuming point. Electric power may flow through several substations at different voltage levels. Uh, Now we have transmission towers and transmission lines. Transmission towers are most visible components of power transmission system. They are used in high voltage AC and DC systems. A transmission tower is normally a tall steel structure. Its functions is to keep the high voltage conductor separate from their surroundings and from each other. A wide, a wide variety of tower shapes and sizes and designs exist. And now we have transmission lines. Uh, Electric power is transmitted at high voltage to reduce the energy lost in long distance transmission. Power is usually transmitted through overhead power lines. Underground power transmission has a significant higher cost and greater operational limitations, but is sometimes used in urban areas or sensitive locations. There are several types of hydroelectric power plants, but we have listed out some commonly found hydroelectric power plants. Uh, One such is impoundment. The most common type of hydroelectric power plant is an impoundment facility. An impoundment facility, typically a large hydropower system, uses a dam to store river water in a reservoir. Water released from the reservoir flows through a turbine spinning it, which in turn activates the generator to produce electricity. The water may be released to meet changing electricity needs or other needs, such as flood control, recreation, fish passage, and other environmental and water quality needs. Then we have a diversion type of hydroelectric power plant. A diversion, sometimes called a run-off river facility. It channels a portion of river through a canal or a penstock to utilize the natural decline of the riverbed elevation to produce energy. A penstock is a closed conduct that channels the flow of water to turbine with water flow regulated by gates, valves, and turbines. The diversion may not require the use of a dam. Then we have a pumped storage type of hydroelectric power plants, which works like a giant battery. A PSH facility is able to store the electricity generated by other power sources like solar, wind, and nuclear for later use. These facilities store energy by pumping water from a reservoir at a lower elevation to a reservoir at a higher elevation. When the demand for electricity is low, PSH facility stores energy by pumping water from the lower reservoir to an upper reservoir. During periods of uh, high electrical demands, the water is released back to the lower reservoir and turns the turbine, generating electricity. Now let us see the advantages and disadvantages of hydropower facilities. Uh, Hydropower facilities have a high capital cost but very low operating cost. Hydropower facilities are dispatchable, that is, their owners can, within limits, increase or decrease power production to reflect changes in electrical demand. Hydropower is a renewable resource relying on the natural water cycle. Hydropower facilities produce no air pollution and greenhouse gas emissions are also less. Impoundment facilities typically offers a variety of recreational opportunities, notably fishing, swimming, and boating. But there are also some negative effects of these hydropower facilities. Some of which are hydropower facilities can affect land use, homes, and natural habitats of flora and fauna in the dam area. Reservoir may lead ecosystem damage and loss of wetlands. These are very expensive to build. When dams are built at higher elevation, they pose a serious flood risk to any town nearby that is below it. Now let's gather some factual knowledge. There are some important dams in India and world, some of which are Theri Hydro Power Complex, which has the capability of generating 2400 megawatt of energy. Topping the list of hydroelectric power plants in India is the Tehri Dam in Uttarakhand, the highest hydroelectric power plant project in the country, commissioned in 2006. First construction began in 1978, helped by technical collaboration from the former USSR. Then we have Koyna's hydroelectric project, which has the capability of generating 1960 megawatt of energy. It is located near Patan in Maharashtra, Satara district, close to the Koyna River. The Koyna hydroelectric project is India's largest completed hydroelectric power plant with a capacity of generating 1960 megawatt of energy. Then we have Sri Salam Dam, which has the capacity of generating 1670 megawatt of energy. It is owned by the government of Andhra Pradesh. And now, on the world level, it is the three gorgeous dam in Hubei, China, has the largest instantaneous generating capacity of approximately 22,500 megawatt of energy. With the Iiitv dam in Praia, in Brazil, in second place, which has the capability of generating 14,000 megawatt of energy. Around 16% of total electricity production comes from hydropower, which is surprising. According to the International Energy Agency, China, Brazil, and United States are some of the world leaders in producing hydroelectricity. The best fossil fuel plants usually convert about 50% of its energy into electricity, while many hydropower turbines are up to 90% efficient. In addition, from 1985 to 1990, the cost of running a hydropower plant grew less than the inflation rate, making hydropower a relatively economical process. The fun fact is that Norway gets virtually all of its energy from hydropower. In fact, the country gets 99% of its energy from 20 hydropower facilities. A massive volume of moving water is needed to generate electricity. At a hydropower facility, about 80 gallons of water is needed to generate just 1 kilowatt hour of electricity. Uh, Now, what are the future aspects of hydropower? Hydropower produces three-fourths of the world's renewable energy. That is, it generates 16% of the world's total electricity. The number could be tripled if all available rivers and lake resources were harnessed, resulting in an annual output of approximately 15,000 trillion watt-hours. India has an estimated hydropower potential of 1,45,320 megawatt, excluding small hydro power projects. China unveiled its smartest world's seventh biggest mega hydropower station. China has used some advanced technologies such as real-time temperature monitoring and ground peaking equipment. Moreover, it has integrated technology that can automatically adjust the water flow to realize the cooling process of concrete in most sophisticated way. Damless hydropower plants or run-of-the-river hydropower plants generate electricity utilizing the natural flow rate of water instead of constructing huge reservoirs. Also, these plants cause less ecological impact than conventional dams. The climate change and shift in rainfall patterns, along with the chronic droughts, have already affected the output of hydropower plants. Thus, the use of dam-based hydropower plants presents a compelling alternative.